All right, good morning or good afternoon. We are going to talk about Coulomb's law today. If you have had physics, you probably talked about this and maybe did some calculations with Coulomb's law, so hopefully you're a little bit familiar with it. If not, then that's why we're going to go through it. So Coulomb's law states that the force of attraction between two objects is related to the charge of both of the objects as well as the distance between them. So it can be simplified into this equation. The force equals K, this is a constant, and these would be your two charges. Q1 and Q2 would be your two charges, and then R stands for the distance or the radius or between the two objects. So basically what it says is, if I have two objects, let's say this is a plus charge and this one is a minus charge, okay? That there's going to be a force of attraction between these two, and I can actually measure that attraction. Now, in AP Chemistry and in chemistry in general, we don't really deal with the calculations. What you need to know is kind of the concept behind it. So, and be able to compare two things to each other. So, if I had these two particles, and then let's say these two particles, okay? So let's pretend that they're about the same size. I drew these a little smaller, but let's pretend they're the same size. These two are closer together, these two are further apart. So the force of attraction is going to be greater between this one and this one than it is between this one and this one because they're closer together. And the opposite is true. This one's going to be a weaker force of attraction, okay? And it kind of makes sense. The closer two things are together, the more, if they're oppositely charged, the more they're going to want to be attracted to one another. Same thing is true if they were the same distance apart. So let's say we had two other. So let's say we had this one, and this was a +2 charge and a -2. So these two particles are about the same distance as these two. They're about the same size. But this one has a +2 and -2 charge. So in this case, these numbers would be greater. So this force is going to be larger because you have a greater charge. Okay, so there's going to be more attraction here because these are +2 and -2 than there would be here. Okay. And so what we can do, and what we do a lot of times, is we relate this to the atom, okay? And so we think about the atom. Here's your nucleus. That's going to have positive charge. And here is your electron cloud, the energy levels. And you're going to have little negative charges in each of the, if we think about the, so 2 in the first energy level, 1, 2, 3, 4, 5, 6, 7, 8. There's our 8 electrons in the second energy level, and maybe we have an electron here. Okay. So you got it. What we can figure out then is how would this electron, this attraction here, compare between the nucleus and the electron here? How would that attraction compare to maybe this electron in the nucleus? Well, this one is much further away, right? So this R is going to be huge between here versus this. So the attraction between this electron and the nucleus is going to be a lot smaller, significantly smaller than the attraction between here and here because they're so much further away. The same is true if we think about adding protons to the nucleus, right? If I have 10 protons in the nucleus versus 20 or 30 protons in the nucleus, The more protons I add, the greater the charge is going to be, and the more tightly I can hold on to those electrons. Okay? So Coulomb's law, and we'll get into it more, but Coulomb's law is can explain a lot about how electrons and protons behave within an atom. So I hope this helps kind of explain a little bit about Coulomb's law. If you have any questions, let me know.